looking at this from a general perspective, but in the context of SACNASP, who, for those of you who may not know, are mandated with registering and regulating natural scientists in South Africa. So it is actually a legal requirement that all of those practicing natural science in South Africa should be registered with SACNASP. So then we get to the question, what was and is a scientist? So if we're going to register them, we have to know what they are, and we have to decide who qualifies and who doesn't qualify. And what we've found is that this is a changing thing. It used to be somebody who studied a scientific discipline, and they worked in that discipline, and they probably worked in that discipline for 40 years and did more or less the same thing. And the disciplines were very clearly defined. You could say that person is a chemist, that one's a mathematician, that one is botanist, and everybody knew what you were talking about. Now that's changing. We find people who have studied natural science or a mix of sciences. They may not have stuck to one. They may have mixed it up with a little bit of economics or psychology or something else. The boundaries between the disciplines are becoming blurred. Even with the people who stick strictly within the sciences, we will find people who have thrown together genetics and computer science and then added in a little bit of biochemistry, and honestly, which box do they now fit into? We're not entirely sure. And then they might go off and do an honors in something completely different and really confuse the situation. There's constantly new disciplines. At SACNASP, we have our fields of practice, and then we find people, where does this person fit? We had a discussion the other day of someone who had studied pasture science. So where does pasture science fit? Does it fit under agriculture? Does it fit under ecology? Does it fit under animal science, because the animals eat the pasture? And nobody was entirely sure. And then the other thing is that scientists change during their careers. So someone will start doing something, they may get bored, they may need to look for a new job, and they change, and they do something different. And sometimes it doesn't fit with what they studied. And what does that make them now? So if we look at what does the fourth industrial revolution say that we're going to require from people in order to be adapted to the new situation that is arising. And this comes from a list that was developed by the University of Stellenbosch Business School. And it's very interesting if you look at it in the context of a scientist. So if we look at developing things that are doing things that are not rote or by rule-based, that's what scientists do. We develop new methods. We come up with new ways of doing things. Computational thinking, using data to extract a concept and to prove a hypothesis or disprove a hypothesis. Again, that's what scientists do. This is the heart of what we do. Cognitive load management, being able to handle a lot of information, sort it out, and find the patterns and its usefulness in that data. Again, it's typical of what a scientist does. Then we start getting to the things where scientists are less strong, transdisciplinarity, which is really what we're talking about this afternoon. Because now we need to work together. If we're looking at climate change and we want to know what the impacts of climate change are, we can talk about the impacts on the biodiversity, but we also need to talk about the impacts on the people and on the economy and as soon as we need to do something like that, we start requiring expertise, which is stepping over the line out of natural science into other places. Okay, virtual collaboration, which is just using technology to work virtually, and technological literacy are not really things that scientists generally struggle with, although we have our moments. But what we can see is that the real challenge, if we look at this list that is lying there for us as scientists, is around multidisciplinarity and how do we deal with that. So if we talk about how do career paths look different these days from how they might have looked 20 or 30 or 40 years ago. The days of studying something and doing that for 40 years and doing probably a very similar thing for that whole 40 years are not really here anymore. There are people who do it, but we mix up our studies. Some of us may have still studied fairly pure science, but many also mix in humanities and commerce and things. And many of the universities and technicons are actually starting to offer more and more programs that include these things. Am I still on the right slide? Sorry.
I don't think you are. Yes.
Okay. That include these things, and that's also where we're finding a challenge at SACNASP. So the tertiary institutions are meeting a need that they see in the market, but how do we adjust and accommodate that? Also, many scientists don't work in what we would traditionally see as science. They may not be doing research, they may not be publishing papers, they may be working in industry. What they're doing in industry may or may not be closely related to what they studied. We see a lot of physicists moving into the banking industry, for example, because their analytical skills are invaluable there, and they very easily get employment. But how do we handle that? And then we have people working in multidisciplinary teams and also switching through their careers as they get different opportunities. People adapt these days. There's a new challenge, there's something that needs to be done, and somebody figures out how to do it. They may not have studied it. Okay. So at SACNASP, our challenge is around registering scientists and dealing with this multidisciplinary people that are coming through, which in industry are eminently employable, but then how do we register them? And these are our current criteria for registration, which we often find are too traditional and may fall short on the multidisciplinary people. Because we're looking at things like we want the majority of what they studied to be in the discipline that we're going to register them in. But somebody who didn't study majority anything is obviously not going to meet that. We also are looking at having a broad base in natural science, which is a very good thing, but we do find that some of the people who are a bit more multidisciplinary may not have had physics, chemistry, maths, biology all on first year level, and they may not have that base. And when we look at for example, we require that 100% of someone's honors year is in natural science. So if they start to take maybe some environmental law or something in their honors year, that would immediately kind of pose a problem. So we've been finding that we need to start finding more innovative ways to deal with, people. These old models of, you did chemistry 1, chemistry 2, chemistry 3, then you did an honors in chemistry, so great, you can be a professional natural scientist in chemistry, are just not working anymore. So we have 25 fields of practice, and even with our 25 fields of practice, we have a lot of people that fall between the fields of practice, or maybe fit in 2 of them, or we're not quite sure where they fit. So that also begs the question, how do we divide things up? How do you cover everybody without, having an impractical number of different fields? And we're coming up with good ways to do that. Okay. So we also have recognition of prior learning is a way that we do register scientists whose degrees may not tick all the boxes that we have for them to tick around what degrees you have and what percentage of the subjects were science and things like that. But with that, there's also challenges, because some people will find it a little offensive if you ask them to register through recognition of prior learning, especially if they have a very successful career as a scientist, and now their undergraduate degree is lacking in some areas. And also, how do you apply recognition of prior learning consistently and across all fields, and especially to the multidisciplinary people who often don't fit nicely within a field. So when we're registering people, we take their work experience into account. So we require a certain qualification and then a certain number of years of relevant work experience. And the question, what is relevant work experience, is often a very delicate issue with some applicants, because we had an example of someone who went and studied food science, and then they got a job in a facility producing animal food. So is that relevant to food science? Or is it not relevant to food science? And then we had someone who studied animal science and then started working managing pasture, not the animals. Is that relevant to animal science, or is it not relevant to animal science? And so in our system, we would expect the person's work experience to be in the same field where they studied, but that's often not the case. So which box do you put this person in if they don't fit in a box? Currently, we also only recognize experience after the highest qualification was obtained. So if you got a BSc and then you went to work for a couple of years and you did your honors while you were working and then you got your honors last year, we're going to say, oh, now you have 1 year of work experience, because we count it from the date you graduated with your honors degree, which confuses a lot of people. It's once again built around the old model where you would study and then go and work and then, and one has to say, is that still relevant? So we use referees. When you apply for registration, you have to give us the name of 2 other people that are preferably registered with us, and that can attest to your work and about the quality and your scientific abilities. And we get from them an independent report that we ask directly from them. And so then one also has to take into account that it is a bit of a peer review system, and when people are not fitting into a box that you expect them to fit into, how do we handle that there? And does the referee system, actually give us a way to say that this person is fine? We also have a CPD program, so each registered scientist needs to earn 25 CPD points in a 5-year cycle. So there's been a lot of talk about, could we not use the CPD program and the earning of CPD points to handle people who are maybe not completely meeting requirements because they're interdisciplinary, but that they could build up what they're missing through their CPD activities. Then all of our registered scientists are regulated by a code of conduct. And part of that code of conduct is that you undertake to only do work for which you are competent. So this also raises the issue of, in a world where fields of competence are very blurred, and what one person can do and what another person can do may not be defined by this person is a physicist, therefore they can do these 5 tasks. Should we not trust professionals to know what they're able to do and what they're not able to do? And that's the model that is used by the Engineering Council of South Africa, where the onus rests on the person doing the work to be sure that they are capable of doing it. So where to from here? We, as SACNASP and as a society, need to understand what is a scientist in the new era. We need less rigidity, because the rigidity doesn't work on the new people that we're seeing, and more space to allow people to adapt and move during their careers, not expecting them to stay within one field of expertise. thank you. That's all that I have. There are my contact details if anybody would like them. And yeah, I hope that that gives something to start off the discussion.